Hello, in this tutorial we are going to learn how to use C++ lambda functions as Wi-Fi event handling functions for the ESP32. As target board of this tutorial I'm using an ESP32 Firebeetle board from DFRobot. So, in the previous two videos we have been covering how to register handling functions to be executed when a given Wi-Fi event occurs. And one thing that we have been using is named functions. So we declare the function somewhere else in our code, and then we call a method on the Wi-Fi extern variable, and we pass as input the function that we want to be executed when that event occurs. Nonetheless, since these functions are not reused anywhere else, and in our case, for example, they were very short, one common alternative that we can use for these use cases, and it also makes our code much more compact and personally I believe also easier to read, is declaring those functions in line anonymously, because since they are not going to be reused, they do not need to be named. And then, as I was saying before, inline, which pretty much we see the place where we register the handling function, and right away we can see its implementation, which I believe makes the code simpler when the implementation is straightforward, like we have been covering. So this is just to illustrate and to give you another tool that you can use, obviously outside the scope of registering Wi-Fi event handling functions, because you can use lambda functions in pretty much any place else you want, as long as it makes sense. But in the scope of this tutorial, we are going to see how to apply them to handle Wi-Fi events. So, going right to the code, the first thing that we do, like seen before, is including the Wi-Fi.h library. So we have access to the Wi-Fi extern variable that allows us to both start the connection to the network and then to register Wi-Fi event handling functions. Then we need to declare the credentials of the Wi-Fi network, more precisely the name of the network and its password. So moving on right to the Arduino Setup function, we start by opening a serial connection. This is our usual procedure, so you can then output the results of our program to the serial port, so we can see them with Arduino IDE serial monitor. And then this is the block of code that we are going to focus on. This is where we are going to register our Wi-Fi event handling function. Let me first say that for illustration purposes, we are going to cover the same event that we have been seeing in the previous tutorial, which is this one, system event station got IP, which is pretty much the event that is triggered when your ESP32 gets an IP address. So, and as implementation, just to give a heads up, what we are going to do is printing the local IP address that was assigned at this moment to the ESP32. So going back to the code, as I was saying, so we need to call the onEvent method on our Wi-Fi extern variable so we can register the event handling function. And as first input of this method, we need to pass the event handling function. Recall from the previous tutorial that I've mentioned that this function needs to follow a predefined signature. So it needs to return void, and it needs to have two parameters as input, which are these data structures. One is of type Wi-Fi event underscore t, and the other is of type Wi-Fi event info underscore t. We're not going to make use of these data structures. Nonetheless, these handling functions always need to follow this signature. So in terms of C++ lambda syntax, the first thing we need to do is declaring what is mentioned as the captures. So this is a mechanism that we are not going to cover here, but basically even if our function doesn't capture anything, we need to place here between these square brackets. If we had captures, we would put them here, but since we don't have, we are not using this mechanism, we just put first the empty brackets, the empty square brackets. Then after the captures, what we need to do is declaring the parameters that our function receives. So we do this between parentheses, as you can see here, and regarding the data structures that I've already mentioned, these are the ones that we need to declare here and here. Then one thing that you might be seeing that is missing is the return of our function. In this case, the compiler is able to infer that our function doesn't return anything, it returns void, because we are not returning anything here explicitly, and the compiler can infer this for us. Obviously, there's other syntax for lambdas where we can explicitly also declare the return type of our function, but for here, to make the code even more compact, I'm omitting that part. Then between curly brackets, as you can see here, what we need to do is pretty much declaring the implementation, the body of our function. That, as I've already mentioned, will be as simple as printing the local IP address assigned to the ESP32, pretty much like we did in the previous tutorial with the call to this local IP method that takes no arguments, is called on the Wi-Fi extern variable, and its output can be directly printed to the serial port. And this is it. This is the syntax that we need to use to declare a lambda function. As I'm highlighting here, this is what corresponds to our lambda, or also known as anonymous function, because as you can see here, it has no name. It just have its declaration, but no name is needed because we are not going to reuse it anywhere else. So once this is done, then the procedure that we are going to follow is the same that we have been doing before, is calling the begin method on the Wi-Fi extern variable, passing as first input the name of the network, as second input the password, and then asynchronously the ESP32 should start connecting to the Wi-Fi network. In terms of main loop, we can leave it empty because we don't have any computation to do there in our simple tutorial. So I've already uploaded the code to my ESP32, as you can see here. Let me just run it again so you can see this in action. And as you could see, after the program boots, obviously it doesn't print the IP address right away because it needs to first connect to the Wi-Fi network. But then, as expected, our handling function, even though we were using the lambda syntax, but our handling function was executed. And as you can see, the fact that it is not a named function like we have been using before doesn't affect anything. Everything works as the same. And personally, I believe that the code is much more compact and readable. Naturally, this is, I would say that using lambda functions or not, it's debatable if it makes it more readable or not, simpler or not. My opinion is that it should be used where it makes sense. Going everywhere and start using lambda functions everywhere doesn't make sense if it does make your code more readable. But for example, for these simple use cases, I believe it makes it much more readable and easier to understand. Of course, that for those of you who are not acquainted yet with this syntax, it might be confusing a bit at first, especially this part about the captures. That you can read more in the documentation. I'll leave it in the description of the video, but the syntax may be confusing at first, but after you get the hang of it, it will be very easy to identify where someone is declaring a lambda function and what it does, what are the parameters, what is the return type, what are the captures, what is the body. And once you are familiar with it, it will be a very nice tool to have in your toolset. So this is it. Hope you have enjoyed, and thank you very much for watching.